Hi, everyone. My name is Ina Paricio, and I'm a marketing manager here at EDB. I will be your host today for our webinar, Upgrade Easily with Postgres BDR. I'm joined by Simon Ricks, Postgres Fellow at EDB. Now, briefly, before I turn it over, I just want to go through a few housekeeping items. This presentation is being recorded. We will be sharing the recording along with the slides after the broadcast. The lines are also currently muted, so if you have any questions, just drop it in the question panel. We expect the presentation to last most of our time today, and we'll allot any extra time for Q&A. If we do not have time to address all questions, just know that we'll follow up afterwards so we can answer your question. And now I will hand it over to Simon to kick us off.
Thanks, Ina. Well, I'm going to be talking to you today about how to upgrade easily with BDR. And as you can see, I'm currently at the beach. So if you'd like to spend more time at the beach, just like me, then please use Postgres BDR to do your upgrades. And then you're good. You can go to the beach. So Postgres BDR is the most advanced replication solution for Postgres. And we normally spend an awful lot of time talking about high availability and how that works. And we kind of just say, oh yeah, by the way, it does really good upgrades. And we gloss over that really usually. And so what I'm going to do today is spend a whole hour talking specifically just about the upgrade facility. And as a result, hopefully to have you understand more about that and how you can spend more time at the beach, which is obviously the reason for doing things quickly and easily. So the software stack in which BDR sits is becoming a more complex one. Certainly we have an application that accesses the database. We have BDR, which is an extension within the database, and then that's all sitting on some kind of operating system. So we've got multiple layers in the stack that we need to consider. We need to consider those from different perspectives because each of those components need to be upgraded at some point. And so in this presentation, I'll be talking about system software upgrades, by which I mean the database, BDR, and the operating system, and obviously various packages and tools around that. And then separately from that, the application, because that deserves sort of special treatment and conditions. But we want to know how to upgrade all of those different things. And I'll try to cover that in the next hour. So generally, people say, why upgrade? Some years ago, it was standard practice to basically never upgrade. And you see some systems that have been still on the same old version of Solaris for like 20 years or something. And that's becoming a thing of the past. But the needs that came out of that era are still with us. For example, the Linux LTS kernels are supported for 6 years. Super stable Postgres releases are supported for 5 years. So basically in that situation, you know, it's a reasonable proposition. And I've had various discussions with people at different times. Just why upgrade? Why bother? You know, if your application's working, why touch it? And, you know, that's a reasonable, if it ain't broke, don't fix it situation. But security issues really are driving things now. And a lot of people have compliance requirements that they will upgrade their software within 3 months of a new release coming out. And that kind of compliance requirement is now driving much more frequent updates and upgrades. But really, as software gets more complicated, more critical issues arise. It's simply not possible now to just sit back and say, I'm not going to upgrade my software or my application for years and years. So things have changed a lot. But really what we're seeing with BDR is changing that whole set of thinking completely on its head. And what my question is to you is, if you have BDR and it can do these upgrades, then why not upgrade on a very regular basis? Okay. And then you can take advantage of all of the security protections and all of the bug fixes that we get. So BDR is actually changing the way that we do database software, back from the kind of the dark ages of never upgrade through to the more recent upgrade on a regular basis. So exactly how often do we want to upgrade? Well, the Linux kernel is updated 5-6 times a year. It was updated 6 times in 2020, but the Red Hat Enterprise Linux updates are now consistently at 2 times per year, twice yearly, typically April, May, and sometime November. And that actually matches with the Postgres upgrade cycle, which is 4 times a year, and that is happening in February, May, August, and November on a consistent cycle. And the security team times the release of security fixes into that cycle so that we don't have an amazing panic every time we release a security fix. We just feed those neatly into the normal maintenance stream. But you also need to plan for the fact that you're likely to have somewhere between 1 and 3 bug fixes per year. Now that is not always a bug that you yourself discover the first in the world, but it's a bug that you encounter. Okay, and when you encounter a bug, then you need a fix. Now, obviously, if some of you are thinking, yeah, but we don't really pay for support, and so we want to get by without actually any bug fixes, and you can pretend that Postgres is so stable that it never has bugs. I mean, it does, but you might not be the ones that hit them, or maybe you don't even notice you hit them. But if you're that kind of a person, then we're not talking the right situation. I want to be talking to people that understand the need to upgrade, that want to be running secure, efficient, robust software systems that are sensibly supported by appropriate experts. So in my world, you should be looking to have about 6 upgrades a year, 4 of them hard planned, where we know the specific dates where you've got to do the upgrade, which is good. You can put that in your diaries, you can do it at the weekend or whatever you got to do, but you know the dates that's happening. And then also you should be making people aware that they're quite likely to be another 2 upgrades during the course of each year, and then they're not surprised when they happen. Okay, if you pretend to people that there's never going to be an upgrade, then they are they question you when actually it comes to needing an upgrade. So please plan for that many upgrades throughout the year. Now, so what we're going to do now is go into the details of how upgrading works with BDR. And first of all, let's go through some details of BDR itself. You can see that BDR 3.6 runs on versions 10 and 11. BDR 3.7, 3.7.11 is just out today, and it runs on 11, 12, and 13. And BDR 4 will be out in November this year, and that supports 14 as well as 12 and 13. So that gives you an upgrade path from BDR major version to major version, and that allows you to plan for the way that you're going to progress forwards with your new versions. So this is generally the diagram we use for BDR always on, and this shows that we have the 4 main database nodes in the middle, and then a whole load of other nodes around it for various purposes. And all of this is deployed in a consistent way using TPA exec, and that allows us also to upgrade our systems using TPA exec, and that will that gives us various opportunities to do rolling upgrades of various kinds. So what is a rolling upgrade? Well, a rolling upgrade is something where we upgrade the cluster one piece at a time. So we don't need to take every node in the cluster down to do an upgrade. The idea is that we upgrade one node at a time, and we work our way through all of the nodes until they're all done. Now, TPA exec has got functionality. You can just say, upgrade my cluster, and it will work its way through one after the other until that's done. But what you might want to do is manually control that so that you know which node is being upgraded next, and that allows you to do various things with the application at the same time. So how exactly does this work? Well, all of the nodes are connected to all of the nodes. It's a mesh configuration, and they're all talking together. So you can see that there's actually 6 different communication paths between any 2 nodes in a 4-node configuration. Obviously, the bigger the configuration, the more communication paths. Now, each communication path consists of 4 different connections, 2 in each direction. One is the control path, and one is the main data path. And the communication over those links it uses specific protocols, and those protocols are renegotiated each time we make a link between the 2 databases. So when we are upgrading the first node, as in point 1 on this diagram, you'll see that 3 on the nodes are orange and 1 is green. And at that point, the green node has got the higher release of software on. So all of the nodes that connect to that node will potentially use a higher level of protocol, whereas the other communication paths will stay at the existing lower protocol. And as we move through the system, stage 2, stage 3, stage 4, we update the cluster 1 node at a time until we get through to the end. Now, because we use this specific mechanism, it means that BDR is fully able to upgrade across major software releases. And that means that we can upgrade across operating systems. You could have different operating systems on different nodes. You can have different versions of different operating systems on different nodes. You can have different major versions of Postgres on the nodes, and also differing versions of BDR itself. And that's the way, obviously, in which we upgrade BDR. So that's basically how we do a rolling system upgrade. So what I'm going to do now is I'm going to actually burrow down deep into the mechanics of the upgrade process, so that we can have a look at why certain things work certain ways, how long they take, and the type of considerations that you need to think about. So my starting point here is, if you want to spend time at the beach, you need to spend time in the office testing before you go to the beach, because otherwise you are going to be called back very quickly from the beach to sort out problems. So all of this assumes that you already tested your application on the latest versions, and that you are clear to move towards upgrade. So what I'm talking about is the actions that occur on the production system. So there's a whole load of testing that you'll be expected to do beforehand. Now, if you have automated testing, and I really, really hope that you do, then obviously that automated testing will give you fairly quickly a decent view of how successful that's going to be. But there's no real substitute for a little bit of manual testing just to check everything's working. And of course, some performance tests just to check that things are working sufficiently well that you can run it in production. So that being said, the basic outline for any upgrade is this process flow here. So I've put handle application because obviously I don't know how your application works, but I hope you do. And there's something that you need to do to the application before we do the upgrade. So normally it's some process where you disconnect the application from the database, and then we do something to the database, and then you can reconnect again. Okay, so that's the basic process flow there, but that changes depending on the exact setup that you've got. So I've just put handle application as a sort of generic term. And what I'm going to do is I'm going to compare how an upgrade runs on physical streaming application for a minor and a major version upgrade. And then I'm also going to compare that against how those same two upgrade paths work with BDR replication. And then I'm also got something about the future. So I've actually got 5 different ways of upgrading, and that will allow me to compare and contrast between these different ways of working. So if we're running physical streaming replication, now I know this is a BDR seminar, okay, but I want to contrast how BDR works against how physical streaming replication works so that you can see the benefit, okay? So this is not something that happens within BDR. This is how you are currently doing replication if you're not using BDR, okay? So if you're using physical streaming replication, then typically what we would do is we would switch over the application from the master to a standby, and then we'd promote the standby into a new master. So in order to do that, we need to checkpoint all of the database server, which flushes all of the writes to disk, and then we'll need to allow time for the data to flush to HA servers. When we do that, we will then shut down the server, do the upgrade, start it back up again, and continue using the application. So when we're doing that, there's going to be a short period, depending on how busy your server is, while all of that happens. So there is a small period of time where you're not able to do writes, okay? And that's what happens with a minor version upgrade. And that works fairly neatly. It is annoying because if you've got sort of hyper available requirements like money transmission systems, 30 seconds where you can't take credit cards from people is actually a big problem for the business, okay? But, you know, let's just see that that, you know, doesn't have to happen that often. And so it's something that they're usually willing to accept. But BDR does it better. So let's look at how that's possible. Okay, so if we have a major version upgrade, then switchover isn't possible because you don't have any standbys running at the time that you do the major version upgrade. So it's not possible to upgrade the primary at the same time as you're working on working on an old standby, because the protocols don't work. They're incompatible because physical streaming replication uses the WAL directly, and therefore we have to shut the primary down, which takes a little while, and then we need to do a very fast upgrade. Now, the fastest that we can do that on a really big server is about 15 minutes because we've got to allow for PG upgrade to run. And that's in its fastest mode, okay? So, you know, obviously before all this, we need to do backups and that kind of thing, but they can be done online. But the point here is that with a major version upgrade, we actually have to have substantially more downtime than we would have done otherwise. And in some cases, we have tasks that need to be performed after the major version upgrade. For example, reanalyzing the database and also allowing time for the cache to refill before we can truly say that the application is up and running fully again. Okay, so sometimes there's quite a long curve while we wait for that to occur. So let's now look at what happens with a BDR upgrade. Now, with a BDR upgrade, there's no requirement for us to run a checkpoint. Okay, and as a result, that means that you know, things are able to happen a lot faster. So basically, we just allow time for the data to flush to the high availability servers, and typically that should be less than 2 seconds, because if you're watching your application lag and that's carefully controlled, then you will be able to wait just that short amount of time. So what we're doing here is we're moving the application from one of the master nodes through to another master node, typically from the lead master to a shadow master in the same region, but all the same, no problem, we're able to move the application from one node to the other node, and then we're able to do the upgrade in place, but the app is online against the other node when we're doing that. So even though it takes a few minutes to do this, then that's okay. Now, a major upgrade does require BDR to copy a whole new node into place, okay? So at the moment in version 3.7, BDR doesn't support in-place upgrades for major version upgrades. And just a sneak peek ahead, yes, that's coming in BDR 4, which will be available in November. Okay, so that's just something to think about for that. But with the major version upgrade, what we have to do is we have to add a whole new node to the server. And so one way of doing that is just to completely trash the server that you're upgrading and then copy obviously everything onto that node again. Now, in large databases, that can take a number of hours, but remember, we're doing this while the app is online on another node. So we're not actually doing this and causing downtime. So these tasks take time, but they just don't cause downtime, okay? And so as a result of this, we see that BDR can support both minor and major version upgrades without taking the app offline. And I think that's particularly important. And that is why we do this. It's all about high availability. Obviously, if you need to take your app down for 15 minutes, then that is definitely not 5 nines availability. But so we can genuinely say that BDR allows this and other approaches just simply don't allow it, okay? And what this means is that we're able to take advantage of more frequent upgrades with BDR. And that is really important because it allows us to move the world forwards, both in terms of the application schema, but also in terms of the system software. Now, I haven't told you about how to do the application schema stuff, but we will do. I'll cover that in a few minutes. one thing that we really need to talk about is what happens at switchover, because everything I've said so far is treating BDR as if it's completely connected to just one node at a time. And what you need to do is you need to think about what your application architecture is. Is it session oriented? Do you connect a session and then issue many different transactions down that session? Or is it transaction oriented, where you are able to use a transaction pooler to execute things just one transaction at a time? And also, how do we handle concurrency within the application? Can it run on multiple app servers connected to multiple nodes of a database? And that's a very good question. Some apps can, some apps can't. It's that point that we need to consider actually what happens with BDR. Because if your application assumes that it is only ever connected to one node at a time, then when we switch over from one database node to another, we need to wait for all transactions to complete and all of those sessions to close before we start opening up new sessions on the second node. So when we talk about what is the switchover, what is the failover time with BDR, it really depends upon the application. Because if the application can just simply switch from one node to another, then it's easy. It can be done in 50, 60, 100 milliseconds easily. Okay, but if your application requires that everything is closed down before it all starts up on the second node, then we have a longer period. Now, it's still not very long with BDR. It's still not the 30 to 90 seconds that it can be on single master replication, where we have to wait for everything to flush through. With BDR, the secondary nodes, the shadow masters, as we called them, are already fully available in write mode. And so all we need to do is we need just to wait for the transactions to finish before we switch across. And that's why even if your application is not designed to work against multiple masters, we can do a failover in a very small number of seconds. And so really for the first time, I'm presenting here a discussion about how an application is designed, because some applications are baked in around the single master database concept. They basically assume that there's only one database there, and in order to do a switchover, then we need to shut everything down. But as I said, BDR does support fast switchover in a small number of seconds. But if you design your application in other ways, then it allows you to have multi-node tolerant apps that can run on one node and run on a second node at the same time. And if you have an application designed that way, then it allows us to switch over even more quickly in the case of failure. And of course, there are some people are writing applications that completely assume that they can access any node at any time, which is is potentially a very good way to design an application. But again, that's really within the hands of the application designers to make it work that way. If you are, if you're thinking that the only way to design an app is that there's one database and it always stays the same, it's a very kind of simple design model, then that actually stops you taking advantage of some of the benefits that you can get from an active database system. So some thought is required as to exactly how we do that. but that's within the hands of the application designer, and BDR just allows that to happen. We provide all the facilities that you need if you would like to develop these more complex distributed aware applications. So what we've been talking about here is switching the application from running against the lead master of BDR1, which is the top left database node in this diagram, switching across to the shadow master. Some people some people have got different requirements here with regard to switchover. For example, if you've got an application running in data center A and the database fails, then it's clear that we would want to immediately switch from the lead to the shadow master. But possibly something happens to both of the nodes in that situation, and then we might want, and I say might want, the cluster to automatically restart in data center B. And if you do that, then you probably need a witness node in a third data center to detect that situation. But obviously that can only be done in conjunction with an application that understands that's going to happen. So depending on how we handle the application, that tells us exactly how we're going to manage the switchover and the failover upgrade. Okay, so just to mention a few things there. So what I'm going to do now is talk to you a little bit about how BDR can handle application upgrades, which some people call schema upgrades, or rolling schema upgrades is another term that is sometimes used. So BDR provides for automatic replication. We do automatic DDL replication. So if you create a table, it will take that create table statement and execute it on the other nodes. And we also do automatic DML replication. So your inserts, your updates, deletes, and truncates are all passed across in logical form and then re-executed on the downstream nodes. Now, because we are sending the information in logical form, that allows us to do a number of different things when we replay those changes. So one of the things that we can do is actually add a column onto the table on the target node. And when we do that, the changes can still be correctly replicated. And all we do is we assume the default value for the missing columns. And BDR can be defined so that if there's data traveling from the table with an extra column back to the table with one less column, it can be told to ignore missing columns as well. So actually that can be set up in a way so that you can actually upgrade the database schema for your application. You can actually make changes to on one node. And what this then allows you to do is you can run one version of your application on one node, and you can run a later version of the application against an upgraded database schema on the second nodes. And that then allows you to upgrade your application schema. So somebody was asking what BDR stands for. That stands for bidirectional replication. It actually comes from this diagram here, where you can see the arrows between the database nodes go in both directions between the nodes. And that's how we're able to maintain what we call an active-active database system. Yeah, I mean, basically, you don't need a majority of nodes up and running, but in order to perform auto failover between nodes, obviously it needs to be able to run something like the raft protocol between nodes, and that's based on a majority of nodes being accessible. So if you want to have auto failover work, then you need a majority of databases up and running. But if the very worst situation should happen and you start losing lots of different nodes, obviously BDR can still function when it just returns to just a single node. Obviously, that's not an ideal situation. But that is the way it works. Okay, so that's just a couple of questions answered as we're going along. So just returning to the application upgrade situation, what I was saying is that BDR can actually handle dissimilar definitions of tables on multiple nodes in the cluster, and it can actually handle the transfer of information between the nodes, even if it's got altered definitions. Another thing that you can do, for example, is change the data type of a column on one node. For example, you could change an integer into a big int, or you can change the length specification on a varchar, and BDR will handle that easily and seamlessly. Obviously, if you go down from 1 to 8 to 64, then the apply process will fail if you try to insert a long piece of data. So what you need to do in that situation is put a check constraint on the original node that limits the length of data in that column to 64, and then we can actually change the definition of the underlying column underneath. Okay, so that's fairly straightforward change to do. And obviously it's easy to add new tables into the database schema. I don't think that situation actually really counts as a transfer situation. And what we would do in that particular case is not add the table to the replication set until the other nodes have got the new replication set running. Okay, so this is really quite an impressive capability of BDR, is its ability to handle dissimilar applications across multiple nodes. And what that allows you to do is upgrade the database schema for the application without taking the application down. And I think that's a particularly important point with BDR. And what that allows you to do is run different versions of the application against different nodes in the cluster at the same time, obviously, as long as your application can cope with that. But this is the point, is we're adding new features to the database here that allows applications to take advantage of these new features, new ways of working. Okay, if you just treat your database as a bit bucket and you don't care what type of database it is, then it makes it harder to use some of these features. Okay, but you know, we're not trying to spoil your fun. We're trying to make it easy for you to do the things that you need to do. We're providing features for applications to much more easily allow them to upgrade. So some final points just to make along the way is something to say about how quickly do you need to upgrade. I described it as a rolling upgrade, and the question is, well, how quickly does it need to roll? Do you need to do this really quickly, one after the other, right? Quick fire like that? And the answer is no, actually. You can pause, you can upgrade one node, and you can just leave it running for hours, days, weeks. And so if there's some issue that's only detected after you've upgraded that first node, then you've got time to fix the issue before you move on with the upgrade. Okay, so that's quite a useful facility, is actually to do a really slow rolling upgrade. For example, upgrade one node every weekend for 4 weeks, or as long as it takes until you get that whole cluster to be upgraded. And that's really important because it allows the final production testing to take place on that production system without risking taking the whole cluster down. Okay, and that's again is a very important aspect. There's another thing as well, which is how do you know at what point to upgrade BDR, the database, the operating system? And actually, we do go to some lengths to make sure that the BDR maintenance releases coincide with the Postgres maintenance releases as well. So typically, for example, BDR 3.6 is now in maintenance mode, and you'll see an update to that every 3 months, and that will coincide with the Postgres maintenance releases as well. And as I mentioned previously, the Red Hat maintenance release cycle also roughly matches the Postgres release cycle, in that there's a new version coming out in April, May, and in November. So it's possible to upgrade both or all of BDR, database, and operating system all in one upgrade that occurs on a quarterly basis. So that's very cool that they all coincide. So the process of adopting BDR does need to take into account some discussion with the application owners to understand exactly how the application would work on top of BDR so that we can implement it correctly. And that's why typically when you engage with EDB to talk about BDR, we send some professional services around and we start talking about things like proof of concept, or sometimes call it proof of technology, but it's basically a prototype project to investigate how BDR can be most effectively employed with your particular application. And then obviously there's various rounds of training and such like when you adopt BDR. So that's me. I've actually said everything I wanted to say in just over 40 minutes, as well as answering a couple of questions. So that's very good. Just shows how easy upgrading is with BDR. So if anybody's got any additional questions, I'd be very happy to try to answer them now. So if anybody's got questions, please fire away. Okay, yeah, well, thank you everybody for listening. It's been a pleasure to tell you, as you know, it's quite breezy here on the beach, and so I wish you luck in finding time to spend more time on the beach yourself. So I look forward to talking to you in more detail about the other aspects of BDR and working with EDB. So look forward to speaking to you again.
Thanks, Simon, and thank you all for joining. As said at the beginning of the webinar, we'll follow up with the recording and slides. Until then, have a wonderful day. Thank you so much.
Thank you. Ciao.